Okay. Zoom in on this guy. Oh, I messed with this because of Easter. I gotta mess it all back. All right, so this is section 4.4. Oh no, we should be in 4.5, sorry. Okay. There we are. All right, so we're going to look at solving equations with logarithms and exponential functions. There we go. Nope, that's still 4.4. Okay. So for review, an exponential function is one where the variable occurs in the exponent. All right. Now, some of these can be solved. Not all, some can be solved. Using the fact that exponential functions are one-to-one. We've used this quite a bit already, but to review, this means that if we have a to the x and we know that that is equal to a to the y, then we can say that x has to be the same as y. We have used this quite a bit already, but we've never really stated it. So what we're going to do today is start using some of these. All right. I need my colors. Marker. Marker. All right, for example, given that 3 to the x is equal to 343. If we do the prime factorization of 343, I think that's right. Oh, nope, I didn't want that. Hold on. I think I just put in the wrong number. 243 is what I wanted. My apologies. Okay, so 243 is 3 times 81, which is 3 times 27, which is 3 times 9, which is 3 times 3. So we know that 3 to the x power is the same as 3 to the 5th. This tells us that x has to equal 5. This is the simplest example of that. We can kick it up just a tiny bit if we do something like e to the x squared is equal to e to the x plus 2. Then using this property, a to the x is equal to a to the y, we know that x squared has to equal x plus 2. Now what can I do with that? Well, that's a quadratic. X squared minus x minus 2 is equal to 0. X minus 2, x plus 1. So we would get x could be a 2, or x could be a negative 1. You may want to check those. Which can go pretty quick. So this would be e to the 2 squared is the same as e to the 2 plus 2, or e to the 4th equals e to the 4th. That one checks. And you can do e to the negative 1 squared is equal to e to the negative 1 plus 2, or e to the 1st has to equal e to the 1st. Also checks. Questions? Nope, we're good? Okay. Now, it doesn't always work out so slick. Shoot, that was my phone. All right. All right. What about, let's do example C there. What about something like 5 to the 2x minus 3 is equal to 16? Now, there's no way we can write 16 as 5 to some power. I'm sure 16 is equal to 5 to some power, but I cannot rewrite this as 5 to some power y. It's just not going to happen. So what we do in this case, when we do not have the same base, is we use one of our common logs. So we use the common log, or we can use ln. And once we've got that common log or the ln, then what we want to do is use our laws that we did last week to help us out. Okay, so here's what I'm going to do. I'm going to take the natural log of both sides. I could take log base 10, but I'm going to use the ln in this case. So I'm going to take the natural log of 5 to the 2x minus 3, and that's going to equal the natural log of 16. Remember, we talked about this before too. If x is equal to y, then the ln of x has to equal the ln of y. Same as the exponent law. All right. Now that I've got ln 5 and I've got a 2x minus 3 up there, what can I do? What can I do with that 2x minus 3? Nope, it's not equal to 16. I got to bring it in front. Law of logs says I can take this and pull it out front. So that'll be a 2x minus 3 times the ln 5 equals the ln 16. Now remember, we're trying to solve for the x. So I can distribute, or since this is multiplying, I could divide ln 16 by ln 5. Are y'all okay with that? Yeah. Okay. Now, again, I'm still trying to solve for x. I'm going to add 3 to both sides. And then, again, still solving for x. I want to divide everything by 2. Or, since this is already a fraction, I'm going to multiply by 1/2 on both sides. Multiplication by 1/2 is the same as division by 2. As this is written, it is called an exact answer, meaning I haven't gotten a decimal approximation yet. I still need to plug everything into the calculator. I multiplied this entire side by 1/2, so that got distributed. So ln 16 over 2 ln 5. 1/2 times this, plus 3 times this. 3 times 1/2. So now when I type this in, I'm going to do ln 16 divide, whoops, watch your parentheses, I just caught myself, divided by 2 ln 5 plus 3/2. 2.361 if they want 3 decimal places. Questions? Are we okay? Okay. So you took the natural log of 16, closed your parentheses. Okay. Yeah, and just for ease, Austin, some people would prefer just to do, let's say, an ln 16 divided by an ln 5 plus 3. Get that answer and then divide it by 2. Okay? And that's fine. It's just a matter of, well, it depends how they want it entered into the program. If they ask you for the exact answer, just know they might not take this divided by 2. They might need this as the answer then. Well, like order of operations, Brandon, there's many ways you could type it in. So find, if you just have to type it in and get a decimal answer, find a place that's comfortable for you to do it. If you're comfortable with this and then multiplying by 1/2 or dividing by 2, go ahead and do that. But like when you're required to simplify answers, they may want all of this as an exact answer. You want to try another one like that or similar? Okay. All right. All right, so we're going to solve, let's solve 2 to the 5 minus 7x is equal to 15. Okay. Notice this has a base of 2. I cannot rewrite 15 as a base of 2. So I'm going to need to use either log base 10 or ln. I'm going to use log base 10 this time. As a reminder, it doesn't matter if I use ln or log base 10. They both are serving the exact same purpose here. Neither one is better than the other. I've got the 5 minus 7x up top. I'm going to use the law of logs to pull that out front. So I have 5 minus 7x times the log of 2 is equal to the log of 15. Does anybody feel a need to distribute that log of 2? Okay. So I'm going to divide both sides by log of 2, log base 10 of 2. So now I have 5 minus 7x is log of 15 over log of 2. Trying to get the x alone. So I'm going to subtract 5 from both sides. Now, in order to get the x alone, I need to divide both sides by a -7, or I can multiply by a -1/7. The only reason I would do this, or the main reason that I would multiply by a -1/7, is because I already have a denominator here. I don't want to put this all over a 7 now. It looks ugly. So instead of doing that, I'm going to multiply by a -1/7. On the left side, this gives me an x. And on the right side, I have a negative log 15 over 7 log 2. Minus a minus is a plus 5 over 7. And that's how I would get my exact answer. Yeah, this negative sign could go on the log 15 or it could go up front. Now, if it wants the decimal, I can type in what I have here, being careful about my parentheses. Zero, 1, 5, 6. Or I can use this step because it's a little faster. And then divide it by a -7. Sure, just the calculation? Okay, so either one of these should work, right? I should get the same answer with either one. If I'm going to use the exact answer like this, I just need to be very careful to type it in as it appears. Yeah, you've got to, because if you just divide by 7 and then log 2, without putting the 7 times log 2 here in parentheses, it's just going to divide that log 15 by 7, and then it'll multiply that answer by log 2. And we want it to divide by log 2. I do plus 5/7 as a fraction, but you can hit the equals and then add 5/7. Okay. All right. Okie dokie. All right, let's try a few more. What was that? DE. So this, well, this is, I'm going to go with numbers. This is example 5. All right, so let's try 4, 1 plus 10 to the 5x is equal to 9. I don't know if you can see that that's a 5x there. A little bit better. Okay. This one is a little bit troublesome because we should have the base with the exponent alone. So I don't have the base with the exponent all alone on one side, right? If we look at every other thing we've done, we've essentially had one term on the right side and one term on the left side. This does not give us that. So I need to figure out what algebraic moves I have to make so that I have 10 to the 5x alone on this side. The first thing I'm going to do is divide both sides by the 4. I'm still trying to isolate this term. So to do that, I'm going to subtract 1 from both sides. Now, do you see how we have an exponent, or we have a base to an exponent, and then technically we have a base to an exponent of 1? This means I can now apply the law of logs. So now I can use log base 10, the common log, or the ln. Because this is a base of 10, I'm going to use the common log base 10. This exponent can come out front. And since I have the log of 5/4, I can rewrite that as log of 1.25 if I want. Or this is division. And when I have division, this is the same as log base 5 minus log base 4. I don't know if I need that or not. But I do have this. And since this is technically log base 10 of 10, we talked about it last week, that's just a fancy way of writing 1. So I have x Oh no, it's okay. I was just worried. I get concerned about those Zoom bombers, and then I remember this is not Zoom. Okay. Now, if I need to do this on a calculator, I'm just going to do log base 5 divided by 5 minus log base 4. So far, so good. Okay, I got like 4-ish more. Okay. Whew. Okay, sometimes it's a matter of noticing combinations that could possibly make your life easier. For example, I need to be able to put the bases all on one side. I can combine these if I can rewrite them as the same base. So as you look at these two, is there a way to rewrite 4 using a base of 2? Two to the 2. Now, 2 to the 2 to the x is the same as 2 to those multiplied together, to the 2x, plus 2 to the 1 plus 2x. Okay, I'm about to do a thing, so hold on. On the right-hand side, you have two terms. This term is a 2 to the 2x, and this term is a 2 to the 1 plus 2x. I would like to point out that this is 2 to the 2x plus 2 times 2 to the 2x. Because remember, when you multiply the same bases, you can add their exponents. So this exponent of 1 plus 2x really comes from multiplying a 2 to the first by a 2 to the 2x. How you doing? Okay. All right. If you have an x times an x to the third, that's going to be the same as x to the, because we do 1 plus 3, right? So this exponent here of 1 plus 2x is the same as if I had written a 2 to the first multiplied by 2 to the 2x. See it? Landon, you good? I'm not sure about that. Yep. Okay. Caitlin, you doing all right yet? Okay. All right. So now I'm getting tricky with it. You see how you've got a 2 to the 2x in each of those? So now I'm going to pull that out. So 2 to the 2x has to equal 50 over 3. And now that I have a single term on the left side and a single term on the right, I can use either log or ln. I took 2 to the 2x and I factored it out. So 2 to the 2x, dividing it out leaves me with a 1. And when I take a 2 to the 2x out of here, I'm left with a 2. And 1 plus 2 is? No, it's all right. It's all right. No worries. So now I'm going to ln both sides. And I'm going to have 2x ln 2 is going to be ln 50 minus the ln 3, or x is equal to ln 50 minus ln 3 over 2 ln 2. This would be my exact. ln 50 minus ln 3. There we go. I'm going to divide that by 2. Whoops, I need to use my parentheses. 2 ln 2. Oh, sorry. All right, what you got? Okay. What questions you got? No? Landon, did you want me to go over that one bit again, or are you good? Okay. Oh, okay. All right. So yeah, I do ln 50 minus ln 3, and I get that answer. So I hit equals. And then I divided by parentheses first 2 ln 2. So we would have to basically get the answer. Yeah, we'd basically have to get the answer of the numerator and then divide by the denominator. This piece? Okay. This piece looks very complicated, but really what I'm doing here is essentially an x plus a 2x. and saying, okay, that's the same as x, 1 plus 2. Where this is my x, and this is my 2 times my x. Can you kind of see that? Okay. If I put this in a circle and think of it as one thing, right? There's a circle added to 2 times that circle again. That's a circle plus 2 more circles. Isn't that just 3 circles? So whatever 2 to the 2x is, 2 to the 2x, don't I just have 3 of them here? The original 1, and then 2 more. Yep. This one plus the 2 from here. That's 1 plus 2, which I just said, okay, let's just call that 3. And then I divided both sides by 3. A little bit better? Okay, that works for me. All right, let's see if we can get one more in here. All right, so let's try one more. We're going to try and solve 2 to the 3x plus 1 is equal to 3 to the x minus 2. Now, we have one term on the left side to an exponent. We have one term on the right side to an exponent. So we can go straight to using the log or the ln. And again, it's whichever one you prefer. Most of the time, there's no advantage one way or the other, short of having a base 10 or a base e. So I'm going to do an ln 2, 3x plus 1 is equal to an ln 3, x minus 2. The 3x plus 1 gets to come out front. And that's got to equal the x minus 2 times the ln 3. Normally, we would not distribute. Right? Normally, we have avoided distribution. But because x is on both sides, we must distribute to rearrange. So this is now going to be 3x times an ln 2 plus an ln 2. Has got to equal x times ln 3 minus 2 ln 3. Now that each one of these is a term, I can subtract x ln 3 from both sides. To get my x's together. And then subtract the ln2 from both sides. Are we okay with that? Now I'm going to pull the x out of both of those terms. And divide both sides by the parentheses here. So x is approximately, what do I got? 2 ln 3 plus ln 2. Divide that by 3 ln 2 minus ln 3. And then I need a negative on it. 2.947. Order of operations. So I don't put this into a calculator all at once. I've actually done it both ways just quickly here. Yeah, but put the negative first, and then parentheses, type all this in, and get equal, hit equal. And then divided by, and then parentheses, put all that in. Yeah? Okay. So, yeah, so it's an excellent thing that I split up this section because we got about halfway through it. So the assignment that's due on Wednesday night is practicing these with the exponential functions. And then tomorrow we'll do it with the logarithmic functions. That does tend to go a little bit faster because once you're familiar with sort of manipulating these, it does go a little bit better. But yeah. So hopefully, fingers crossed, you'll get an opportunity to look at it tonight, and we can talk more tomorrow about stuff that may have tripped you up. Thank you, guys. Thanks, Kaylin. You should be able to do most of 4.5A. Okay? So you should be able to make it through most of that assignment that's due for Wednesday. All right? You're welcome, ladies. Thank you. Bye, Caitlin.